All right, everyone. Thanks, Ken, for starting the stream. Welcome, everybody, to this Java Champions. Wait a second. I need to turn this off. To this session, domain-centric, why hexagonal, onion, and clean architecture are answers to the wrong question and what to ask instead. I hope you had fun with all the awesome talks that I've seen in the schedule. I had the chance to watch a few of them, but if you didn't or hadn't, then definitely make sure to watch a couple of those. This one is or might not be as Java centric because it's domain centric, right? In the title, it might not be as Java centric as many of the others, but it's something that in my work and looking at Java applications that are built out there is a hot topic and it's coming up like repeatedly. So my name is Oliver Drotbom. I work for in the Spring engineering team at a company called Broadcom. I've done so for more than almost 16 years now. I spent most of my time in Spring Data, designing the data access APIs that you're probably familiar with if you've ever touched a Spring application. That project's maintained by an awesome team these days. I've moved on into, let's say, slightly more architecturally related work, which means that we're looking into our customers or users' architectural ideas to make sure that we're not getting in the way, like Spring as a framework and Spring Boot and the entire ecosystem, or even help them to tackle a couple of problems they run into when designing architectures in a certain way. The most prominent name of that is probably the Spring Cloud project, right? So once you're starting building distributed systems, you run into a particular set of issues. And the Spring Cloud project gives you tools to actually tackle those. There's another relatively new project that I started a couple of years ago called Spring Monolith that tries to do the same thing or the same problem-solving approach within an individual system, right? So it could be one of the 15 microservices you build, or it could just be like a single system or what have you. So the fundamental idea or a starting point of most of my talks these days is that is this slide here actually. When I review the talks that I've given in the last couple of years, it all boils down to this thing, and in particular the aspect of many teams focusing on like building new software or the way that technology is marketed these days, right? It's like, oh, here's this cool new thing that you can use to build something, and that's pretty cool, and you should use that. Unfortunately, most of the teams that I see do not spend their work in this little green area that I have on a slide here, but they rather spend mending and altering existing code because they need to adapt the systems to new requirements, right? And so I'm a focus, or part of my the focus of my work is that how can we make actually, or how can we enable Spring developers in particular, or Java developers in general, to write more maintainable applications, because that's where the actual challenge is, right? And that might mean not, or deciding not to do something that might just like, oh, we can just do that to get a quick result in the first place, but rather like perform some extra effort to then create some software that's more maintainable in the long run. There's a pretty great talk by Kent Beck. Sorry, forgot the name. By Kent Beck, called A Daily Practice on Empirical Software Design, YouTube link on the slide, which ultimately refers to a book by Larry Constantine and forgot the first name of the first guy, Jordan, The Fundamentals of a Discipline of Computer Programs and System Design, which is or Kent points out that like one of the core observations of the book is that the cost of software is roughly equivalent to the cost of change. And he ultimately points out there's actually only two categories of things that we do to existing software. One is we either increase its value, or we try to increase its value by adding new features, or we try to reduce the cost, right? So of that particular piece of software. And The book, I actually got the book to further review it after you mentioned it in the talk, and it like goes quite a bit deeper and into this like what's the cost of software thing, and opens up like a bit of a trajectory to what I'm trying to get to ultimately. Bear with me for a minute. So in the book they say that like the cost of change is roughly equivalent to the coupling of the individual pieces within that software. So what does that mean, or how do they actually define coupling in the first place? In the book, they define coupling as whenever you have, let's say, a set of elements in your code base, classes, methods, packages, what have you, and you need to change one element of that set, right? So let's say this thing up in the upper left corner here, and you then need to change to adapt to these changes. You need to also change another node and another node and another node and another node. That's how they define coupling. It's not a metric or like anything that you project on, let's say, your code base and your Java code base, and then you find the classes and the packages and how they relate to each other. That's all like technical representations of this kind of coupling. But ultimately, it's like whenever I need to change something to adapt to a change in something else, that's creating coupling. And coupling is not a static thing. That's why I just mentioned the static analysis tools that you can let's have a look at your piece of software. But coupling is not a static thing in terms of it depends on like under which kind of context you understand that coupling. Let me give you an example. Let's say you have an application that separates the database access from your business code. We're going to get to more concrete examples that in a second of that. And you have, let's say, a database access layer implemented in JDBC, and you have that separated from your domain logic. If a new requirement comes in that says, oh, we need to switch to a MongoDB or something like that, you can actually change that database access layer from JDBC and to move that to MongoDB. So it's decoupled from the business code in that sense that you can perform a certain change to the software system relatively easy. And there is some kind of cohesiveness between the or in that database abstraction layer. That said, if a new requirement comes in to say we need to add a new form field to our registration form, there's a different kind of coupling going on, right? You need to change the DTO that maps the request. You need to change probably the database table or document that you need to, in which you need to persist the data to. So you have more like a vertical coupling in your application, right? From the UI to the database. And that code is still coupled, even if you kind of try to decouple it from the in like business from data access, right? So that's when I think that's the way Kant phrases it, not all coupling is born equal, right? So you have different kinds of coupling in the system, and also like what would be our natural reaction to some kind of coupling within the system? We would try to decouple things from another, right? And that kind of is where the question comes in, like, what do you decouple from what, right? So as I just mentioned, there's like business logic from persistence operations, or is it maybe the registration form from our order fulfillment? That could be a different kind of decoupling criteria. But it turns out that, like, as everything in software, decoupling has its cost too, right? You need to introduce additional elements. You need to introduce indirections that actually make that path that I just had in that graphic even longer, right? One other thing, and like there's a lot of talk about decoupling software and like internally and systems from each other. So this entire decoupling theme has been like present in the last decade at least, within the context of microservices as well, right? We want to write decoupled systems and what have you. Something that's not that much looked at is a counterpart of coupling, which is cohesion, right? And cohesion actually is a form of coupling, which is kind of like, okay, where does he want to go with that, right? It's a bit of a hat scratcher here. So cohesion is coupling put into exactly the right places, in the places that we want coupling in, right? So let me give you an example of that. Or no, let's move that to later when we talk about our software structure. But it's the point of like we're trying to basically assemble elements that we intend to change in the course of a change requirement, and we want to place them as close as possible to create that kind of cohesion, right? Because it's the elements that we need to change together, and that's how we want to group these, right? So ultimately, software design is the act of modeling units of strong cohesion that are loosely coupled to each other. To make that a bit more graphic, it's kind of moving from this picture where like everything is quote unquote related to everything. So we have a highly coupled system. There's like, you can argue this is very cohesive, right? If there's, let's say, other boxes that contain the same, roughly the same amount of nodes and relationships. But what starting from this picture, what we actually want is this, right? We want like a group of cohesive elements that we can then basically, kind of wrap a box around or a circle around in this case here, to ultimately be able to do the following, right? If we now have a change that starts here, we want that change propagation to be contained within the element, because otherwise that kind of indirection doesn't really have an effect, right? So whenever we design, we create these kinds of software structures, whether it's classes and methods, or it's packages and classes, or it's build modules in a system, or it's even like systems and the individual parts that go into whichever system. Ultimately, and that's how I try to phrase this like cohesively, and like almost, well, pretty much around a year ago, is that the software system structure that we deploy for our application, and that we create, is formalized back on the change patterns that we anticipate having to deal with, right? So we basically expect some changes to a system, so we better design our software to be able to accommodate those changes quite well, right? So we actually we came here, right? We're saying, okay, this is where we want to have or this is the roughly the abstract structure that we want to create, right? We want our changes to be contained in these kind of grouping elements here, but these grouping elements, as they are right now, do not actually form a system. According to systems theorist Russell Ackoff, a system is not the sum of its parts, but the product of their interactions. I'm pretty sure you've heard this kind of quote in some derived form, one way or in one way or another. There's like two important aspects here. Like, of course, the product is product instead of sum basically expresses that there's a greater benefit than the individual elements just on their own. But the more important bit here is that it's the interactions that actually create that added value, right? So these groups here, these groups of elements, do not really form a system, and they do not really add value unless we actually connect them again, right? And making these connections is deciding which parts of these elements, of these circles here, are accessible by others, and then how these interactions between these elements look, right? So it's the classic, you can even argue it's modular design, right? We form a box or a circle in this case. We decide what's in and what's out, and we try to minimize the interaction on the outside, and we try to maximize the relationships on the inside here. That's kind of our design goal, to support change on our software system. So now let's put that aside for a moment and see what kind of like approaches to software decomposition have been popularized in the last, I don't know, 15 years, right? I usually group those under the term of separation of concerns architecture, but yeah, you'll see what we get to in a second. The first one that I just briefly want to introduce and basically describe how it works is hexagonal architecture, or ports and adapters architecture. It basically assumes that we have some kind of application core that contains the business logic, and that business logic does not know anything about like any kind of technical environmental aspects like persistence, or whether that application or that domain code is exposed via a web application or a Swing application or a JavaFX application these days, right? So we have this kind of surrounding elements, or these surrounding elements called adapters. They interact with the file system, and these that basically allow us to connect to the outside world, right? Connect the application inbound through some controllers to talk HTTP, REST, GraphQL, what have you, or messaging, and on the outside, or on the outward path, we usually have I don't know, any kind of file system adapters, databases, and the important bit is that parts of the application core are going to be designated as ports, which then these implementations either refer to. That's for the driving adapters, as they're called, or the driven adapters. They implement those ports, right? You have a JDBC repository implementation, and the port would be your repository interface. You had your Spring MVC controller, and then your port would be your service interface, right? This could be, we're going to talk about like code structure later on, but this is kind of the idea. Sorry about that. 3 years later, Geoffrey Palermo, I think was his name, coined the term onion architecture. It was basically doing similar things. So it argues that there's a domain at the center of our application, which is where the talk title was derived from, and there's an application ring around it. So you have like application-specific abstractions, like an order process, and the order and zip codes. These fundamental things are part of the domain. And there's an order process that's application-specific that would reside in that ring. And there's an infrastructure ring, and the important bit being that only the outside is allowed to access the inside, right? So it's a bit of a simplified approach, but it's looking very similar. Right, so you have controllers and HTTP, JSON endpoints in the infrastructure ring, as well as database access and let's say messaging or sending out emails or what have you. Any kind of infrastructure is in the outside ring. So when you look at both of these approaches from a layered architecture perspective, or from how do they differ from a layered architecture? So layered architecture was like, I think the first, it's probably been circled around in other forms, and especially in more 3-tier architectures, like when it was more about like where do you deploy which system. And also I think the REST dissertation references layered architecture, but for software structuring purposes, the first real appearance I have found, or I've known about, was Eric Evans' domain-driven design, in which there's a presentation layer, a business logic layer, and a persistence layer. And yes, the blue book talks about the business logic depending on the persistence. That's, if you meet folks new to domain-driven design, or like very enthusiastic in the first place, they often cannot really believe that, but it's actually how it was defined in the book. The thing that hexagonal and onion architecture actually bring to the table here is the following. So we start at the same model, but we invert the lower arrow here. So that's kind of what we do, like outside in instead of like top to bottom. And what they more or less formally do, like hexagonal more than onion, is that they introduce like interfaces, right? They basically say, not in terms of necessarily Java interfaces, but here's a dedicated piece of code, or some piece of code that's designated the entry point into that abstraction, right? And that the ports basically for hexagonal architecture. But that's effectively it, right? There's not much more to it. And it gets even more underwhelming if you start to think about the way that Spring applications in particular, I think like many of the applications in alternative stacks would kind of look the same, right? So when we started building Spring applications in 2004, we started with like controllers, simple form controllers back in the days, accessing services, and those accessing repositories. So dependency injection is a very important topic here, right? So because it allows us to compose these elements in a way that, if you think about it in layered architecture terms, you have the presentation depending with a constructor argument on a business service, right? That could be a service interface, but it doesn't necessarily have to. But you use dependency injection to hand in the lower layer element into the upper layer element, right? The business, then the service, would then refer to the repository. The repository implementation would refer to a data source. So it's turtles all the way down, right? So you could argue that typical arrangement is a layered architecture. You can like put aside your layered architecture hat and put on your hexagonal architecture hat and argue, well, the controller is a driving adapter, and for the service we introduce an interface, and for the repository we introduce an interface. So make this basically, move this to the service here, the port basically, and then have the repository implementation refer to that port. So we move the interface from the repository to the service, and we're good. We basically created a hexagonal architecture approach with 99% of the same code base, basically. And the same goes for onion architecture, right? So your controller belongs to the infrastructure ring. You have some application domain, you refer to that, and there's some infrastructure that would then implement some kind of abstraction within what's previously been a service, right? So the important bit here is that what we're actually using to implement all of these is dependency injection and more or less a few interfaces, right? So that's kind of the thing. That's why I'm so constantly surprised that there's so much buzz around these approaches, when it's actually like, for someone who's built Spring applications for like, what is it, like 22 years now, you've kind of been doing all of this from the start. It's more of like someone described this kind of approach a bit more precise and used some certain terminology to describe that. So the terminology aside, what are the goals what were the intentions that these architectures, I really think it might not be or it's a bit of an exaggeration to call these things architectures, because as I said, it's basically dependency injection and interfaces. And but still, like, why did both Alistair and Jeffrey come up with these ideas? So one very important and very great goal is testability of these applications, right? You have to think about that, the fact that both of these approaches were introduced in the early 2000s, when people were deploying applications to application servers, and then like they packaged those up into giant zip kind of like files, deployed them to an application server, then got like two coffees to drink, and then that thing was bootstrapped. So the entire feedback cycle was like totally incomparable to what it is or can be with modern technologies. Period. Right. When Spring was around, and it wasn't the first dependency injection container, but it's been massively popularizing that dependency injection idea, which ultimately led to the fact that you can go ahead and just write a unit test for your domain logic, right? And that's not changed. You can do that today. You could do this more than 20 years ago. So it's not been necessarily something that was a bit there was a big problem, at least in the Spring ecosystem, right? Even the integration test story, it's been dedicated support for running and bootstrapping application contexts that are much quicker to start than those application server deployments were back in the days. I have to mention test containers here, right? Because infrastructure of any kind, bootstrapping database containers was a big problem in those years, right? So you definitely wanted to avoid references to all of that kind of infrastructure. Whereas today, bootstrapping a Postgres and then reusing that for your 1,000 integration tests is not a problem at all anymore. It's like 2 lines of Java code and annotation. So that picture might have changed, right? I'm going to get why I think this is important. The other aspect is we want a technology-free domain. And I've always struggled with that argument. So what it means is that our domain code is supposed to be independent of, let's say, references to a particular technology, coupled to a particular technology, because we might want to get rid of that. Or it, of course, in often cases, might harm the testability, right? Using JPA in your JPA annotations is considered, depending on who you talk to, right? Like, do we really want that? Because we already kind of decide for a persistence mechanism, and our domain code should not be dependent on the persistence mechanism. So what does that even mean? Or where do we draw the line? Is a JPA annotation on the code really preventing that code from being unit testable? Of course it's not, right? There are certain other aspects around JPA, like the requirement for a default constructor, that might severely impact our design abilities for that code. There's definitely a point to that, but it really gets a slippery slope, right? Before we had a proper datetime API in Java, people were using JodaTime, like pre-Java 8, I think. So would that be considered a dependency that is not allowed to be have in domain code? I mean, we're writing code in Java, right? It's like there's no such thing as technology-free domain, right? So we already decided we project our code base into a certain set of technology. So I usually think it like there's two aspects to consider here. It's like, one is what do we get for that dependency? So how much value add do I get? And you can argue that with JodaTime, it was a proper datetime API, and it was very worthwhile having those that dependency. And the other bit is like, how easy is it for me to get rid of the thing, or how does like moving to something else affect my code base? And especially in the Spring universe, over the like I think versions 1, 3, and 4 in particular, we've very much moved to, or we're focused on allowing you to write code that's depending as little as possible on Spring abstractions, right? Especially code that's at the core of your application. That's your domain code. You don't need any kind of Spring annotation on a Java class to actually get that to become a Spring component, right? That's often misunderstood. People still at autowire their constructors. If there's only a constructor, you can just use that, right? You don't need add component at your class. You can have a separate thing that's then like composing code in a configuration class, and basically, here's my class, here's how you provide an instance for it, right? So there are already, like, if you use like technology that doesn't ignore this kind of aspect, then you will find ways to actually get to that, right? Without, and now coming back to the topic here, without relying or having to rely on this kind of machinery of ports and adapters and what have you. My biggest pet peeve with these things is like, they are often, I deliberately do not call them domain-centric architectures, but they are actually called these or that in a lot of places because, understandably so, they both put the domain at the center of their abstractions, which is honorable, as I said, especially given the history. But if we accept that the domain is the center of our application, then decomposing that domain is the primary activity that we need to that we need to pursue, right? So we actually need to find ways to group these bubbles that I had on the slides before, right? In a way that we can support domain-related changes to the system. How often did you actually exchange your JDBC data access layer against a MongoDB data access layer, right? That's kind of, it's a very technical view on the system. And it's, of course, we as technicians, we're usually looking at stuff that way. But think for yourself, like how regularly do you get requests that affect the application because of some business requirement that changes versus a technical requirement, right? And the problem I have with, it's not really a problem, but if an decomposition approach like Hexagonal and Onion architecture does not give answers to that question, how do we actually do that? Then they are not or cannot be our primary decomposition principle, because they're not solving our core problem, right? Decomposing the domain into manageable parts that we can change with the least cost possible. There's been a blog post of mine from I think 2 years ago or something, where I kind of suggest like what to do with this, right? Given we have this kind of arrangement, whether it's hexagonal or onion architecture, how do we actually turn this into a multiple of things, right? So we do not have one domain. We have, let's say, our order domain, we have our shipment domain, we have our inventory domain, right, in our system. So how do we like make this work in such an arrangement? So one could be like just have these onions, like have an onion per subdomain, quote unquote. But that would kind of incentivize like these things interacting. Remember, I mentioned that the interactions between these things are the important parts, and making them horribly difficult and effortful, right? So we would not be able to just call a method over there, but we need to go through some infrastructure, or as many of the proponents of hexagonal architecture suggest, you actually go through and you call a port from the inside, and then there's an adapter talking to another adapter going through a port, and like then you have like 5 abstractions that you need to go through to just like invoke one thing on the other side. So what do we do instead? We slice onions, and as you can guess, there's usually tiers involved, right? So it's not something that's simple, but like bear with me. I get there in a second. So the idea being, okay, if we cut off the onions here and on the left, on the right, the application ring actually gets surfaced to the left and right, and we can combine multiple of these sliced onions and wrap them up to actually form a system, which is kind of already getting into like, okay, we have, let's say, orders and shipment and inventory domains, and we can basically structure the system that way. So internally have basically 3 major folders packages. We're going to get to that in a second. And then have like everything that's related to that, the entire controllers, data access assigned to these areas, right? And those can then establish interaction by exposing events, right? Or in the Spring word, expose instances, or dedicatedly expose instances of beans, of classes, for availability for others or to call, right? So we can actually have this exercise of establishing the blue dots I had in the slide before, right? Would be exactly that exercise, deciding which of the code we actually put into the API of these things, so that they can be called from for others, or from others. And if you look at that, you actually get to you realize that what's going on internally, whether it's an onion or an internal hexagon or what have you, is not really important. We're going back to the concept of a module, right? A box or an abstraction that allows us to hide things that are internal, and also hide the structure of how such a module works, and deliberately expose APIs for others to call or consume events or what have you, right? If you want to read more about this, there's this blog post linked here. But we can make the important point here is that let me jump back to this one here. Yeah, we can reestablish the events and beans. I see many people's or many teams striving for this kind of consistency across the vertical slices, right? We say, okay, whenever we develop in hexagonal architecture, which means that every slice, no matter how complicated or not complicated it might be, will need to follow those structuring rules. It doesn't necessarily if you go with that, right? And that, while I can see why you would want this particular consistency across these slices, it might just sometimes make sense to not enforce that, because there might just be, I don't know, there's a module that only needs to expose a couple of database tables via some JSON API, and then you can be much simpler. We're going to get to that in a second. Whereas a module that needs to, I don't know, interact with some payment APIs, external APIs, you would want to definitely have some abstraction and adapter for those APIs in place. So the complexity that you need to hide inside this module really follows the complexity of the individual subdomain here, right, or the module. All right. It's been very abstract until now. Let's get to a bit more, let's say more practical here in terms of like code structure. So the plant that I wanted, or the seed that I wanted to plant here, is that we actually want to create cohesive elements to support changes that are driven by the business, and we want separation by business domain. That's what we kind of want. And how do we actually reflect that in our code base? There's the section here is severely inspired by Simon Brown, and an observation I made returning from a customer 10 years ago, that in many applications you can basically find out about the book that an architect just read most recently by looking at the structure of the software system, right? I mean, like hexagonal architecture was all the rage back then, so you usually found some ports and adapter folders in your code base, so you could really you find out about like what inspired the structure here. But ultimately, let's have a look at how we could basically arrange these different kinds of architectures in our file system for development in Java, and what they would actually look like, and what effect we actually create by doing so. So let's have this let's start with layers, just to give us a bit of a baseline. So in this, we would create these let's say an order controller. The blue things are interfaces. So we have web, service, and persistence as packages, because developers like to find things according to the abstractions that they're thinking of, right? So we have our layered architecture, so we have packages per layer, basically. And then we establish the relationships, right? The implementations depend on the interfaces. The interfaces are implemented by, more or less specific implementations, right? So that's kind of fine. So let's have a look at like how would we do this with or what happens if we add a new vertical slice, right? So we have some kind of different business functionality. We usually replicate that arrangement, right? So let's say we have our order management or our customer management, and we basically replicate that into the same folders, and we're good, right? But are we really? Because what we're creating here is like, it's basically turtles all the way down, right? The packages act as units of like grouping, at least, like they are the circles around or dots from the slides before. But unfortunately, we're not creating any cohesion here, right? The more slices we add, more vertical slices, the less cohesion we have, because the order service usually doesn't have much to do with the customer service. Even worse, in the adapters space, right? The controllers usually don't depend on each other. Order repository, God forbid, it actually deals with the customer one, right? So we're not creating the cohesive elements when we actually started with the idea that we wanted to have cohesive elements. Okay, So layered architecture, or like applying layered architecture to packages, doesn't really seem to be achieving what we want here, right? Okay, but we want decoupling. We want to get rid of the service to persistence dependency. We want to do hexagonal architecture. So how do we do that? As I said, we move the repository interface into the domain package, because we're now using the terminology of hexagonal architecture. Like web is an inbound adapter, and the JDBC order repository is an outbound adapter, and the interfaces are basically our ports, right? So that looks much better, right? So we've decoupled things more, right? We've basically got rid of the service dependency onto persistence. So we have our domain completely decoupled from our persistence and web implementations. So what happens if we add a new domain slice here? Yeah, it's kind of the same, isn't it? So we still have low cohesion between the elements. So the controllers don't really depend on each other either. The repositories hopefully don't, as I said. And there's probably, or there might be a bit of interaction. Let's say, I don't know, the customer is asking for it to be deleted because of a GDPR requirement. So we probably have to mask the orders a bit. So there's some interaction, I guess, right? But still low cohesion, and it's not really what we wanted. So what can we do instead, really? And if we start with if you think of the onion again, it's like, why don't we just start with a like business-driven decomposition in the first place, right? So we just say, okay, we have our orders, and we put all of the same arrangement. We can just put it into that orders package. But you can ask, like, what's the difference now? We still have the same thing, right? I mean, we have a few packages less, but it probably might just like totally explode if we add more of these like additional slices to that single package. So we end up with a giant package. It's not what we want. But let's not get ahead of ourselves here. The important bit is that in these other two approaches, we actually need to make way more elements of our code base public than we actually should have to have, right? So order service and order repository have to be public if they are put into separate packages for the code in the other packages to be accessible, right? And that's kind of, while it's not technically a detriment to the cohesion thing, it kind of already feels like that, right? So why is that? Why do we need to expose these things that are internals to our vertical slice, really? In our modular approach, we can basically just have no code public whatsoever, because Spring MVC will happily call like order controllers that are an order controller that's just package protected, and it's all injection from then on, right? So if we have it's a new vertical slice, we can actually do the same here. And then, of course, if we run into the situation in which the order service actually needs to talk to the customer service, then all that needs to be public is the customer service interface. So we can really be selective about designing the APIs of our business-driven modules, right? And we're still doing hexagonal architecture internally, right? We just need to basically declare our repository to be an adapter and a controller to be an adapter, the implementations. The customer repository and order repository would be the ports, and the customer service would be a port as well, right? That's used both internally and, let's say, from the order service. But we dramatically reduced the number of public elements, which also means that no other module can accidentally call that thing, right? In the hexagonal onion column here, there's this risk of someone not calling the order service but using the order repository directly, because they can just, as I phrase it, the architectural violation is just an add auto wired away, right? So if you have want to avoid that, you don't get around the compiler. I mean, of course, you try to use reflective tricks, but usually that kind of, it's not, I'm not even saying that we we must not expose these things. But whenever we try to, we at least trigger a conversation of whether that's a good idea, because someone would need to change the visibility of that thing to public. Right. So again, this is basically like the in this case a bit more like the onion architecture approach, but ultimately we say we consider the thing a module, and whatever goes on internally, and that's what I'm trying to get to, is depending on the complexity of that particular module. So again, if there was, let's say, a customer slice, that all it needs to do is like just read some database tables and expose that as JSON API. Why would I need to introduce all of that ceremony of a controller and a service interface and repository and abstraction? I just go ahead and have a Spring MVC controller and wire JDBC operations, and then use my SQL skills to just like issue that database query. And there's nothing wrong with that, because there, in this case, there's no business logic that we need to separate from the infrastructure code to test in the first place, right? So I'm of course exaggerating, and I've yet to see like a non-complex or a non-trivial application that would like literally allow me to do that. I'm deliberately exaggerating here to allow you to basically free your mind to say, okay, what's the easiest thing that we can do? And of course, you can go ahead and hide customer controller in the first place, and then have nothing else access that, and be very selective about like how much complexity you introduce before you to solve a particular problem, right? And it would be just fine to have your, let's say, hexagonally shaped orders package reside just next to the very pragmatic no abstractions customer package in the very same application, because the important bit is not what's going on inside, but the boxes that we've built and how we connect them to each other, right? Because then again, we can actually get to the fact that we hopefully can change our decomposition, or cannot change our code base and only touch certain parts of it. If you start with that, it's actually, you actually get like with your Git commit history, you actually get a kind of a architectural fitness function of your decomposition approach, right? You can check whether your Git commits are scattered changes around the code base, or whether they actually contained in certain areas. And you can, by that, you can verify whether your decomposition approach is one that actually supports the changes. To summarize, I tried to summarize that a while ago, is that, okay, we need to, with our decomposition support, we need to, or decomposition approach, we need to support change to our system, because change is what drives the cost of the software. And we want to contain the effects of a change to as few as possible elements, right? And if your decomposition strategy does not align with that, it's distracting at best, harmful at worst. So let me just get to try to summarize what we've talked about. If there's one thing you take away from the talk, it might be a bit a while or something to chew on a bit, is that you should be designing for cohesiveness, because that automatically leads to decoupling, but not vice versa, right? So the hexagonal architecture and onion architecture are very much centered on, oh, we design for decoupling, which unfortunately doesn't lead to cohesive elements, which we strive for to support change. If you turn it the other way around, if you design for cohesiveness, so what belongs to the order process? What belongs to the inventory? And where is the boundary between the two, right? Then you automatically get to elements that are decoupled from a like functional decomposition approach, right? Phrasing this slightly different, it's basically functional decomposition over technical decomposition, right? The first level decomposition strategy should always be driven by the business. And whatever else follows or any kind of technical decomposition follows that. And what follows is defined by the intrinsic complexity of the domain. or that part of the domain, right? Intrinsic meaning, as I said, like, is there any business logic? Is it just data access, just reference data? And based on what we find out about that is we choose a particular technical decomposition strategy. Yeah. Encapsulation over organization is, again, the fact that we don't want to use packages solely for grouping elements that are the same, because grouping same elements usually means that you don't form cohesive elements, right? The analogy I usually use here is if you have your flat and you put all your chairs in one room and all your tables in one room and all your closets in one room, that's incredibly helpful if you spend your entire day answering the door and someone's asking for tables or what have you. It's totally not helpful to organize your flat that way if you want to have friends around and dinner with them, because then you need to combine the individual pieces to give you value add, right? There's one more thing which I invite you to look at before we probably, if there's some question. I wasn't able to follow the chat, unfortunately, but there's one more thing. As I said, or as you probably realized by now, is that I often find teams that buy into a particular, let's say, high-level decomposition strategy or architectural or design language that they want to apply to their code base. And what I found through the years is that when you look at the way we get our applications presented to us by our IDEs, it's totally not on par with the mental model that we have about our system. So let's say we want a modular application and we want hexagonal architectures. Wouldn't it be nice if there was a way for us to actually look at the system and then find aggregates, find adapters, find ports in a guided way, in the proper way that we think about the model, right? So I don't know, business first, technical decomposition later, and then have other things. So there is a tiny project I didn't mention that too much. It's called JMolecules, which allows you for Java to actually assign these architectural and design roles to elements of your code base. So you can say this repository is an adapter. This repository implementation. This repository interface is a port. This web MVC controller, Spring MVC controller, is an inbound adapter, for example. And then you can get to the IDE to present you exactly that structure, right? So this is like a sample project I use in all of my talks, basically called Spring RESTbox. Is a web API. It doesn't really matter what's in here, but you see that the IDE has some knowledge or abstraction knowledge, right? It knows it's a Java project. It even knows it's a Maven. It realizes it's a Maven project. So there's this concept of a source folder, and there's this concept of packages, right, in this thing. And we get these presented, but it's actually just a tiny bit above the file system, right? But what if we could look at the very same project in this way? We could say, this is the RESTbox project here, and it has 1, 2, 3, 4, 5, 6 modules, logical modules, vertical slices, basically. And these vertical slices, the payment one is using hexagonal architecture inside, right? So there's an application core, and in that application core, we're using domain-driven design apparently. So there's some aggregate roots, there's some technical abstractions like exceptions, there are identifiers, there are services from domain-driven design, and there's certain other abstractions, right? And then there's a primary adapter, which is the web controller. There's a primary port for the service, and there's a secondary port for the repositories. In this case, there's not even a secondary adapter because we're using Spring data here, and that's kind of it's basically generated at runtime. So how does this work? It actually works by, these types use the JMolecules library to add this metadata to basically assign these code-based elements to the design language that we that we want to use. And then for each or the JMolecules ships with a description JSON that basically says, okay, everything that's where is secondary port, everything that's assigned to that annotation is or has an annotation of that kind is assigned to the concept of architecture hexagonal secondary port. And there's a group, a stereotype group as we call it, called hexagonal architecture. The IDE, in this case, it's the Spring support for VS Code is these files are actually shipped with jars you have on your class path with the JMolecules jars. VS Code considers those, and you can then go ahead and decide which of the overall design and architectural elements that you have in you or that you use in your project you want to pull into that tree, right? So if you're not interested in the hexagonal architecture assignments, you just go with that, and then that just changes to, oh, in payment we have request mappings, we have aggregate roots, we have representation models for the Spring hypermedia stuff, what have you, right? And even better, it's not only restricted to your to the predefined ones that we ship here. You can actually go ahead and put a description file into your very own project. I think that one here has one as well. It's a meta-inf JMolecule stereotype groups. Yeah, there should be a core. Where is it? Yeah, there we go. All right, so it's a class here. We just introduce an interface and we say, okay, we have the concept of DTOs in our code base. We just annotated with add stereotype. There's a bit of stereotype groups here, a bit of additional metadata. It says RESTbox is the group, and we assigned, I think, the DTO to the RESTbox group here. And that means that in our payment module, we see that DTOs group here. We need to work on the pluralization of that, but the payment form is implementing this custom stereotype. You can actually create these stereotypes yourself and then basically get the IDE to present the code base to you on the level of abstraction that you'd like to see, right? This is currently available for through the Spring tools for VS Code and Eclipse. I know the IntelliJ guys are already working on something like that. They have the first part of it already for, this is Spring Modulith modules here. That's already available in JetBrains, but I'm pretty sure that there's going to be something as sophisticated in idea as well that what we already have here. And with that, I think I'm good. I'm not really sure whether is Ken still around. It's probably hard for me to. Where do I see the live chat? Is there? I see something opening here. Let me go here. Classy slides as usual. Thank you, Robin. So in the end, in Spring, it's all the same, all done by DI. That was a question that's been made. Well, I think there's not much difference. So if you're using DI and you kind of separate web code from business code, from repository data access code, then or any kind of integration into messaging or what have you, then you already get to what Hexagonal and Onion architecture promise you to give. That's probably my whole point, right? Testability and technology-free domain is what you get as a side effect. So you don't necessarily need all the ceremony in terms of like package naming and class naming and what have you, to get to what these architectures try to achieve. And that's what I'm usually trying to get to, right? What's the goal? How do I achieve that? And what's the easiest way I can get to that? Ironically, as I think, is that this often, especially the literature around hexagonal architecture was like, oh, we started with projects and there's no way we can actually, it's all scattered around, like all the code is scattered around, it's all entangled, and there's no way for us to see the business logic anymore. I think over the last 2 years, the hexagonal architecture sample applications that I've seen are just a bloody mess of 50 packages with indirections, and you again don't really see where the actual business logic happens, right? It's it's getting excessive pretty quickly. You might argue that's just a matter of applying it more carefully, but I have yet to see a very, very concise and application that that really carries the hexagonal architecture terms in itself, but at the same time is not a complete like mess of like 50 packages that have 2 classes in them or something like that. I don't want to blame hexagonal architecture per se for that, but I think the approach that you see here with, let's say, like business driven packages, and then the assignment based or made on the where is it, payment service, basically saying that this is a primary port, that feels more natural to me, because it still allows you to keep, again, the things that are cohesive, that belong together in that very package. And yeah, that if that package becomes too big, it might usually just be a sign that you're dealing with too much. But if you create for a package for the ports and a package for the adapters, then you're just like constantly jumping packages. It might be a matter of taste. I totally get that. Right? Just think about it. If there's nothing like entirely wrong, and I hope I got across that I still see that value in the fundamental approach. I just see it basically overblown into the structure a lot. You do modular architecture with Spring Modulith. That's, yeah, I mean, I'm the project lead of Modulith, so in the Spring world, I think it's a very good idea, because it not only it gives you the structural guidance, but also like additional features that you don't necessarily get with alternative modularization approaches. Like in Modulith, you get the entire documentation of the individual modules, of the surfaces of the individual modules. You get integration test support of like run the payments. In this case, you can actually just run the payment module in a test, right? So vertically slicing your applications to run integration tests. There's tons of other stuff. Of course, if you already use like Maven modules or the Java platform module system for modularization, like don't do away with that. I usually think they are like a bit too technical to what they want to achieve, or what usually teams want to achieve, especially the Java platform module system, because it's been designed to modularize the JDK, and there's quite a few features missing to make it a fully capable application module system. That said, it's been a great thing for the Java platform for that to evolve, and I totally understand why you would not want to overload it with additional features that made it more more suitable for application modularity, but at the same time just complicates the thing for what the team actually wanted to achieve, right? So there's a balance to strike there. But whenever you're like doing anything modular already, stick with that, and then maybe have a look at Spring Modulith and see whether moving to that would help you, give you anything. Like the structural view, I like that a lot as well. How does it apply to a multi? Dusko asked, how does this apply to a Maven multi-module project? The question is a bit of how does this apply mean here? Are you here, Dusko? Or no, this if you think it was a pleasure to watch it, you're very welcome. So as I said, basically, if you're doing multi-module projects already, don't immediately throw them away. I often think that you can like simplify these arrangements into let's say a single module or a fewer module multi-module project, because you can then use the build module arrangement to shape that around the artifacts and the way your clients consume artifacts. I've just been with a customer recently that they came from a 250 OSGI bundles application, and they were actually building 2 kinds of applications for that from those 250 artifacts, and we just reduced the number of build modules to I think 5 or 6, because they were assembling these 5 or 6 into different applications, and every other level of modularity was then realized through Spring Modulus internally. So yeah, you might find cases in which you want to cater different audiences with the different levels of modularization approaches here. All right, and with that, are we good?
Hi, Oliver. Thanks
Hi.
for the session. Sorry, I got a bit late on your session because I was
No worries,
having
no worries
some
at all.
troubles.
All good, all good. Good to see you,
Uh,
definitely. It looks like we don't have any further questions to answer, so then all that's left to me to say for me is enjoy the rest of the conference and definitely watch the other talks. There's been a few really great ones. Thank you for your time.
Yep. Thank you for the session. Thank you guys for watching. Thank you very much.